Welcome back to the Azure Security Data Lake setup. By now, you should have a storage account with containers that have your data. That data should be in a semi structured or structured format, and we recommend Parquet. Now that data is there, you need a method to access it. You might want to do searches, look at dashboards, run analytics, or even summarize that data back into Sentinel. The way we do that is Azure Data Explorer. So let's start. We first go to Azure, we search for Azure Data Explorer clusters, and we create a cluster. Let's choose our resource group, and let's choose a globally unique cluster name. Now, an important setting here is the region. We want to make sure this region is the same region as our storage account because we want the least amount of distance between our data and the compute. Next, we get to choose a workload. I'll start with a dev test, but if you have a production workload, you might want to start with a compute optimized, extra small or small. In our case, we're not storing data in Azure Data Explorer. The data lives in the storage account, so we don't need a storage optimized cluster. Let's go back to dev test. Since I chose a dev test, I can have one instance, but other clusters will likely have a minimum instance count of 2. Keep that in mind. We have some other configuration items available to us. Right? In my case, I'm going to breeze through. Let's look at system assigned managed identity. We will be using this later on. It's important to make sure that this is on. All right, that's all the settings I wanted. Let's go ahead and create this cluster. Azure Data Explorer clusters do take some time to start after they're deployed, so we'll be back once it's ready. See you then. You should now have your Azure Data Explorer cluster set up and ready to run. The cluster should be in the started mode. If it's not, change it from stop to start, wait a few minutes, and then come back. Before we start using the cluster and the databases inside the cluster, we need to make some changes. First, let's make sure we have the current permissions to start making changes to the cluster. So I'm going to add myself as an admin role here. And that's going to be step 1. I've been added as an admin. Now let's go to the Identity tab. And here we'll notice that the system assigned managed identity is on. That is good. That's what we want. Just want to validate that. Let's go back here. Let's go to databases. And let's add a database. A database is a logical container in the cluster where you run your searches, store your tables, and so on. So here we're going to put in a database name. I'm just going to call this database 1. Here, notice we have some retention policies, cache periods in the database. In our case, we're not storing data in this database, so we can just go ahead and create this. Now, we do need to go back to the storage account and give permissions for this cluster to access the storage account. So you see we're back in the storage account, and let's go to IAM, and let's add a role assignment. Here we want to give storage data blob reader. or storage blob data reader to the identity of our cluster. So select members, manage identity, and here we're going to choose a Data Explorer cluster, and we're going to choose a newly created cluster. Let's go ahead and assign. This is going to allow the cluster to query the storage account and access the files in the storage account. Now that that's done, we have our setup complete. We can start going into the cluster, and we're going to go to query, and we see here this is our empty database. Right? In this case, there's nothing stored in the database, and it still doesn't know how to access the storage account data. And that's what we're going to do next. So you'll notice that I just pasted in a query in the Data Explorer cluster database. And what this query does is it's the first step for us to start accessing the data in the storage account. So in order to access the storage account, we need to create an external table in the cluster. But before we do that, we need to know the schema of the data. So for example, when we search for an IP, it actually knows, Data Explorer actually needs to know what field it's referring to. How does it access that field? What is an IP field? Is it an integer? Is it a string? And we're not going to fill out the schema manually. We're going to use something called schema inference and just check the results. So how did I get this query that you see here? It will be posted on the GitHub page under ADX, but you'll also notice there are a few components. So if you look at line 3, this is the actual URL to my storage account. In this case, I'm going to need to change the storage account name to the storage account name here. I copied over. Also, we'll notice that after the URL of the storage account, I have the container name. In this case, we're going to go to the Palo Alto traffic container. In this case, since we're inferring the schema, we don't necessarily need to look at every single file. We're just going to sample. So let's go to Palo Alto traffic. Let's go here. And let's just grab this day's worth of logs. Again, this is not the final table. This is just for storage schema inference. Okay, next, line 5, this is our file extension. You might have JSON. In our case, we have Parquet data. Line 6, this can either be blob or storage. The new keyword to use is storage. Line 7, we'll dive into a little bit later. This is just saying how to search those storage accounts, how to search the storage account container for different files. So we're saying in this case, we're going to look for a partition by minute bins in this format. How do we know that? Let's go back to the storage account. So we have year, month, day, hour, minute. So that's reflected here. Year, month, date, hour, minute. And then again, our data format is Parquet. And we run this. One thing to note is, in this case, this is a one-time command, and you will need a storage account key pasted here. I went ahead and pasted the key and got the results of the search. Here are the results. Like we mentioned earlier, this is actually a mapping of the field names to the field types. So in our case, we have source port, that turns out to be an int. We have DST, that turns out to be a string. So this is what we're going to use in our next query. So let's grab this and store it in a notepad. So what we want to grab is the output that we see here, from the beginning of the very first field name to the end. We don't want this CSL schema header. Let's copy this. All right. Before we're ready to create the external table, we need to run one more command, and that's going to be this cluster policy command. We don't need to know too much about this. This just allows the cluster to use its managed identity to use the external table. So we're saying this cluster can now access a storage account using its own identity. Now that we run this, we're ready to create our external table. Now we can put everything together. You notice that the search I just pasted in the chat has a few components. Now this is a search that creates the external table that is then used to query everything. So we'll notice on line 1, we're naming the table, in this case Palo Alto traffic. In the parentheses here goes the output of the first command we ran. So the CSL schema goes in that parentheses. On line 2, we're saying this is a storage account we're accessing. Line 3 is the partitioning. So we're saying create this column name ingest time. Now that column name contains, if we go back to the storage account, the column name contains this file path here. So we're saying in this case, ingest time is the 14-minute bucket of the 2-hour bucket. So the ingest time is 2:14. So it's reading the container name, putting that into a column. And that's given by lines 3 and 4, the path format and partition. Line 5, again, is Parquet. That's just data format. This could be JSON in your case. There's also other supported formats. Line 7, again, we're referring to the storage account. In this case, we don't want to narrow down the containers more than just a high top level container, which is in our case Palo Alto traffic. We don't want to narrow this down to a date range or hour range. It's going to be our external table. And then here, instead of using a storage account key, we're going to use a managed identity. Since we ran the last command and we've given access to the storage account from this cluster's managed identity, we can start running the search. So let's run this. We see that the external table creation succeeded. And just to make sure, let's open a new query tab here. And let's run this command. This command is external table Palo Alto traffic. That's indicating that Palo Alto traffic is an external table. We can't just query Palo Alto traffic like other tables. It does need to be enclosed in this method. And then we're going to run take one just to make sure that there's some data in there. Congratulations. We now see data from the data lake in Azure Data Explorer. We see all the columns from our CSL schema that we inferred available for querying. You now have a Data Explorer cluster that points to your data lake for external table queries. We're going to be using these later on for summarization, dashboards, and analytics.